Okay, guys, here is the solution to the problem that we were working on the other day. Okay, let's see here. There we go. Nitrate, remember that nitrate carries with it, this is the formula, and it carries with it a -1 charge. Okay, looking at to start building the principal skeleton structure, I'm going to take a look at my electronegativity chart to figure out which one is less electronegative. Okay, the least electronegative I can tell you right now is going to be nitrogen, and I confirm that by looking at my chart. So I'm going to go ahead and build the principal skeleton structure. As nitrogen is going to be my center atom, okay, I'm going to have oxygens around it. Since there's 3 oxygens, I'm going to draw 3 oxygens around it. Okay. Then in order to build the structure, I need to do my AVBN method, okay? The AVBN method is as follows, okay? Okay, A represents the amount of space available, right, for electrons. Spaces for electrons, okay? Now, in order to calculate the spaces, it's really simple. I mean, I know that nitrogen, right, has space for 8 electrons, 2, 3, 4, 5, 6, 7, 8. Oxygens have the same amount of space, right? So it's going to be, for nitrogen, it's going to be 8 times 1. 8 times 1. Right? Which gives me 8, obviously. And then for the oxygens, it's going to be 8 times, since there's 3 of those, 8 times 3, that gives me 24. And if I add those together, I should end up with a total of 32 spaces for electrons, right? So remember, the spaces is the space amount or allowable for electrons to go on around the atom, right, in the cloud. So all these elements, most of the time, are going to have those 8 spaces, okay? Now, we got our spaces. Valence electrons. Well, valence electrons has to do with how many valence electrons these guys actually have, okay? So we're taking a look at nitrogen, for example. Even though nitrogen has spaces for 8 electrons, when it comes to actual valence electrons, it only has 5, right? It only has 5. Oxygen, even though it has space for 8 electrons, right? It only has 6 valence electrons available, okay? So let's go ahead and add these up. For nitrogen, okay, so for here, it's going to be the actual amount of valence electrons. Now, you guys should know how to calculate these already, right? Okay, so nitrogen has 5 valence electrons, so 5, and there's only 1 nitrogen, right? So that should give me a total of 5 valence electrons for nitrogen. Oxygen has 6 valence electrons. There's 3 of those. So 6 times 3, that should give me 18. If I add those up, I should end up with 23 valence electrons. Okay. Now remember, this guy has a -1 charge. So that means that somebody, we don't know who, is carrying an extra valence electron somewhere. So all we're going to do, because we don't know which one, we're just going to add 1 more electron, one more valence electron to our total to take us to 24. 24 electrons. Okay. All right. Now, we have our total for our valence electrons. We have our total for our spaces. So now what we got to do is we got to figure out our bonded electrons, okay? Bonded electrons. So how do we do that? Well, it's a simple formula. To figure out your bonded electrons, what you're going to do is you're going to take the amount of space available, okay? And you're going to subtract from that the amount of valence electrons, right? So it's a simple formula, A minus V. So let's go ahead and take that. A, we know that we have 32 spaces, right? We want to just abbreviate spaces. We calculated in our V that we actually have 24 valence electrons. So you know what, just to kind of keep this together here, let me go ahead and change the color. So we have 32 spaces available. I'm going to abbreviate the space again, okay? And we've calculated that we have 24 valence electrons, okay? So if we take that difference, right, we should end up with, let me change my color here, 32 minus 34, that should give us a total of 8 bonded electrons. 8 bonded electrons, okay? So if we have 8 bonded electrons, to determine the number of bonds that's going to give us, number of bonds, it's another simple formula. You take the amount of bonded electrons and you divide that by 2, right? Therefore, if I have 8 bonded electrons and I divide that by 2, I should end up with 4 total bonds. 4 total bonds, okay? Now, we have our skeleton structure, so let's go ahead and add our 4 total bonds. Take away these spaces here, okay? So I'm gonna add my 4 bonds, okay? Now, there's only 3 oxygens, right? So how do I add 4 bonds? Well, here's what happens. I have 1 bond here, I have 1 bond here, and I have 1 bond here. The 4th bond can get added to any one. So I'm just gonna add it here. So there's my 4th bond, right? That means that one of these oxygens is going to have a double bond. And that's exactly what's going on here, okay? We have our basic structure now. So now all we gotta do is we gotta figure out how many of those electrons are non-bonded or lone pairs, okay? So let me go ahead and do one more color here. All right, so our non-bonded electrons are gonna be the electrons that are not involved in a bond, right? These are the lone pairs. So this is another simple formula, right? To figure out the non-bonded electrons, we take the amount of valence electrons, the V, okay, and then from there we subtract the number of bonded electrons, which is the B, okay? So if I substitute these values in, I'm gonna go ahead and do that now. I know that I have 24 valence electrons, okay? And of those 24 valence electrons, right, we calculated that 8 of them are bonded. We have 8 bonded electrons, right? So to determine the amount of non-bonded electrons, we simply subtract those 2. Okay, 24 minus 8, that should give us 16 non-bonded electrons. Non-bonded electrons. So my duty now is to go back and add all those electrons to make sure that everybody has a total of 8. Remember that each bond, right? Each bond has 2 electrons on it. So you have to count those as 2 for this oxygen. So this oxygen has 2, 3, 4, 5, 6, 7, 8, right? Okay. This oxygen has 2, so that's 3, 4, 5, 6, 7, 8, right? Now, if I take a look at these, right, I added 6 here, that's 12, so I need to add 4 more. 1, 2, 3, 4. So if I look at all my non-bonded electrons, I should have 16 non-bonded electrons. So let's take a look. Starting here, let's count all these. That's 6. This guy adds 12. This guy adds 4. 12 plus 4 gives me 16, right, which is how many I needed. Okay, and then the nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. Everybody has 8 electrons. Okay, everybody has 8 electrons. I'm going to scroll this up real quick. Okay, so here is my structure. Okay, I have nitrogen, oxygen, 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 with a double bond here, okay, to this oxygen. And around this guy, I have non-bonded electrons. And there they are, okay? Okay. This is your structure. Now, we have to make sure that this is the final structure. So in order to do that, we have to calculate the formal charge. Okay? Let me go ahead and change this to blank again. So formal charge, right, is equal to the valence electrons minus the non-bonded electrons minus the number of bonds, which is bonded electrons divided by 2. Remember that? Okay, so let's do nitrogen. Nitrogen formal charge. Okay, so here we have, let's see, valence electrons. Well, we know that nitrogen had 5 valence electrons. Nitrogen has 0 non-bonded electrons. Non-bonded electrons are these unpaired electrons. You see them? Nitrogen doesn't have any, so we're going to put a 0 for that value. And then we subtract the number of bonds, right? So nitrogen has 1, 2, 3, 4 bonds. 4 bonds. Let's see. Oh, no, wait. Yeah, 4 bonds. So that gives us a formal charge of 5 minus 4 gives us a formal charge of -1. Let's do oxygen. We'll start with this guy right here. Okay, oxygen. So in this case, oxygen has 6 valence electrons minus 4, let's see, non-bonded electrons, 4 non-bonded electrons, minus number of bonds, bonded electrons by 2. That should give, well, you can see them here, it's 4 bonds, right? 2 bonds. So 6 minus 4 is 2, minus 2 gives us a formal charge of 0. Okay, now this oxygen over here is a little bit different. So we're gonna do, let's see here, 6 valence electrons minus 6 non-bonded electrons minus number of bonds, which is 1. 6 minus 6 is 0. So this guy has a -1 formal charge. So the formal charge is so far is here, -1, 0, -1. And since these two oxygens on the left are the same, we can assume that the formal charge here is -1. You with me so far? Okay. Now take a minute, okay, pause the video anytime you need to, and make sure you're getting all this stuff down. All right, let's see here. Sorry guys for that long pause. I had some issue with the audio. Okay, so this is where we're at, right? You got everything down. We got all the formal charges of sorry, this is a +1. I made a mistake there. We have all the formal charges of all the elements. Now, ideally, we want this charge here to be as close to 0 or 0 as possible. In certain situations, you can do that. In certain situations, you can't, right? And that just has to do with the amount of electrons that certain elements can hold. Nitrogen cannot hold any more than 8 electrons. It's not there. As you move down the periodic table, that changes, but we cannot add any more electrons to nitrogen. So this one has to stay the way it is. Now, here's how it happens, right? If you look at the formal charge of oxygen, you have -1 and you have a -1 for the 2 oxygens, right? So that gives you a total charge of -2. The nitrogen contributes a +1 charge, right? +1. So if I have a -2 and I add 1 to that, then I end up with a total overall charge of -1, right? Remember, the oxygen on the right here does not contribute a charge, so it's 0. So the overall charge of nitrate is where we get that -1. Okay, that's where we get that -1. So the structure for nitrate is going to look like this. Okay, I'm going to add all my non-bonded electrons. okay? And then I'm gonna draw my brackets around it, okay? And the overall structure, I'm gonna erase this here real quick so it's not in the way. The overall structure is going to have a -1 charge, okay? This is nitrate. Now, earlier we made the decision to put the double bond on the oxygen on the right, right? Well, it doesn't matter which way you do it because when you move that double bond, okay, you can move that double bond up here. And when you do that, we call this a resonance structure, okay? So a resonance structure is all the different ways that a compound can be created. So when you're doing a Lewis model, okay, when you're doing a Lewis model and I ask you to give me all the resonance structures, this is what they would be, okay? And there's one more resonance structure, which is going to have the double bond over here. Okay, and that's it, guys. This is how you do Lewis models. Make sure that you pay attention to the resonance structures and to the formal charge because they need to be there, okay? The formal charge for each one of these guys is going to be, this is going to be a -1. This is going to be a 0, +1, and a -1, -1, -1, 0, +1, and the same thing up here, +1, 0, -1, -1, to always end up with an overall charge of -1. Okay, guys, there's the video I said I would make for you. All right. Make sure you're taking down notes, and if you have any questions, let me know.